This is number 7 from the homework set from page 836 of your textbook. For this one, we're dealing with some exponents, and that makes the algebra a little easier, but it makes it a little harder kind of to see what's going on sometimes. So I thought a video would be helpful on this one. Remember, when we're proving by using mathematical induction, we have 2 steps. Well, kind of 3 steps. We want to show that n equals 1 works. We're going to assume that the k case works, which k is just a general any integer. And then we prove that k plus 1 works. And this works for proving something because we're showing that 1 works. We're showing that a number at least 2 bigger than 1 works. And then we can say everything in between works as well. So, the n equals 1 case is the first one we need to do. We're doing n equals 1 for this problem. We just want to show that 2 to the n minus 1 is equal to 2 to the n minus 1. So, 2 to the 1 minus 1 equals 2 to the first power minus 1. 2 to the 1 minus 1 is 2 to the 0. 2 to the first is 2. 2 to the 0 is 1. 2 minus 1 is 1. So our n equals 1 case is true. Now we can deal with now we go forward with the next step. So we set it up. If our base case is true, using k's, now I've replaced k's, or I've replaced the n's in the problem with k's. So if this is true with just k's, then it should be true with k plus 1's. So you'll notice this is exactly what's above. I've added the k plus 1 term. And over here, wherever there was a k, I've added k plus 1. And now we go on with our algebra. So what we can do is from above, we know that the stuff I underlined in pink there, all this stuff, that's actually the same exact thing we have up here. And we know what that's equal to. That is equal to 2 to the k minus 1. So I'm going to replace this whole thing with 2 to the k minus 1. That's going to happen every time you have one of these series problems. And then we just want to add what we had here. And we know that is equal to, or we're proving that that is equal to 2 to the k plus 1 minus 1. Once we do that step, now all we need to do is algebra. So let's work this forward. I'm going to work with the left side. So I have 2 to the k plus 1 minus 1. These parentheses don't matter, so those cancel. So I have 2 to the k minus 1 plus 2 to the k. I think it'll help to group these together a little bit. 2 to the k plus 2 to the k minus 1. Now here's where you have to be good with your exponent rules. Here with 2 to the k plus 2 to the k, we have 2 of those. So we can write that as 2 times 2 to the k. Since we had 2 of them, we wrote it as 2 times 2 to the k. Now that is 2 to the first, which is really important. And you'll remember from your exponent rules, whenever we have the same base, which we have the same base here, 2 is our base for both of those. Whenever we have the same base and we're multiplying bases, we can add our exponents. So we could rewrite, I needed to add a new page there, so I'll write that over. And I'll write our goal as well, 2 to the k plus 1 minus 1. So whenever we have the same base, we can add our exponents. So we could rewrite this as 2 to the 1 plus k. And since with addition, the commutative property holds, order doesn't matter, I can write that as 2 to the k plus 1. And now both the sides of my proof are the same. So the way you would end this is by saying either QED, if you remember what that means, or you can say conditions 1 and 2 are satisfied, therefore the statement is true. And that's the end of your induction proof.
Made with Doodlecast Pro.